The displacement x of the spring is measured in centimeters from the equilibrium position of axis 0. The value of x can be modeled by the following second-order differential equation, where t is the time measured in seconds after the initial displacement. Given that y is the derivative of x with time, shows that derivative of y with time is equal to this expression. The differential equation can be expressed in the given form, where A is 2 by 2 matrix. So first of all, you should understand that this dot implies what? Derivative with time. So it's dx over dt, and hence 2 dots, it means what? The second derivative with time. And we can find the exact solution of such second-order differential equation only by using the next method, when we represent it as a coupled differential equations, and then solving using method which involves eigenvalues and eigenvectors, and actually general solution is the formula is given in the data booklet. Otherwise, it will be the Euler's method with the calculator. So how to do that? Here it is given, but in general you should understand that you should use the next substitution to denote the first derivative or just derivative to be any letter. For example, let it be y. So when y is derivative of x with time, so when dx over dt is y, then the second derivative dx over dt squared is what? Dy over dt. And hence our equation becomes dy over dt plus 3y plus 1.25x is equal to 0. And together with dx over, I write it up, dx over dt is equal to what? Y. And what can we solve? We can solve like this: dx over dt, dy over dt is ax plus by is cx plus dy. So to find the exact solution, and using the formula given in the data booklet, the form must be like this only. There may be x, y, or y, z, but notice that x, y, so x, y, not y, x, or something like that. Don't get confused. So according to our situation, it becomes what? Dx over over dt is what? 0x plus 1y. It's not necessary definitely to write 0x and 1y. I do it it to be more clear. And dy over dt is what? Negative 1.25x minus 3y. So you can see x, y derivatives with time is equal to something x, something y. And in matrix form it becomes x dot y dot, or dx over dt, y over dt is what? Matrix with 0, 1, negative 1.25 minus 3, and what? X, y. If you multiply these two matrices, you can see that it becomes like this, and you should be able to rewrite an expression in matrix form as simultaneous equations. It's actually method. Here it is given how to do that, but in general you should understand if it will not be given what substitution you should use, or something like that. So B. write down the matrix A and find eigenvalues and the corresponding eigenvectors. Why? Because solution what x and y, if there are dx derivative, dy derivative, so solution x, y is given by the next expression, some constant e to the lambda 1 t p1 plus b e to the power lambda 2 t p2, where lambda 1 lambda 2 are what eigenvalues and p1 p2 are corresponding eigenvectors, and that's why we need what? We need to find eigenvalues and eigenvectors of this matrix. How to find eigenvalues? We consider determinant of given matrix and minus lambda on the main diagonal, so it becomes 0 minus lambda minus 3 minus lambda 1 negative 125 and is 0. What is determinant? This product minus this product, so it's minus lambda multiplied by minus 3 minus lambda minus negative 1 0 25 times 1 is 0. So it becomes a lambda 3 plus lambda. We can factor out minus here, and it also becomes plus 25 1.25 0. Here is 0. Then expand to get quadratic equation. It becomes lambda squared plus 3 lambda plus 1.25 is equal to 0, and it's called a characteristic equation. And solving it, we get two values of lambda. You may use some product rule or calculator. I will discriminant and 1 over 4 is 5 over 4, and I'll multiply every term by 4. It's necessary, or actually it's not required. Discriminant is b squared 9 minus 4ac 1 and times 125. Yes, it's not necessary to multiply because you can see it's 5, it's 4, and lambda 1 is minus b minus 3 minus root d over 2a, and it's what? Negative 5 over 2, and lambda 2 is what? Negative 3 plus 2 over 2 is what? Negative half, and we need corresponding eigenvectors. For lambda 1 is negative 5 over 2, and to find eigenvectors, we should consider what? Our matrix multiplied by a vector is equal to lambda multiplied by a vector. It's actually a problem on values eigenvector, and so it becomes our matrix. It's 0 1 negative 1.25 negative 3 multiplied by unknown x y components of our required vector is equal to negative 5 over 2 x y, and we need to write it in as simultaneous equation, so we just multiply two matrices on the left hand side and the equating rows on the left hand side and right hand side. So it becomes 0 times x plus y. We just multiply matrices, so it becomes y is negative 5 over 2 x and negative 125 x minus 3y is negative 5 over 2 y. Let's multiply by 2 the first, so it becomes 2y is negative 5x, and it's important direction only, so we can choose any values for x and y, so that it must be true, and usually we take the least integers. So we can choose, for example, y to be negative 5 and x to be 2, so negative 10, negative 10. But the second must be also true. Let's check. 0.25 times 2 minus 3 times negative 5 and minus 5 over 2 times negative 5. So it's what? It's negative 2.5 minus or plus 15 is what? Plus 25, it's 12.5. Yes, it's true, so it's correct. And do the same for another. Lambda 2 is what? Negative a half. Negative a half. And the same, 0, 1, negative 125, negative 3, x, y is negative a half, x, y, and it becomes what? 0x plus y is negative a half x, and the negative 125x minus 3y is negative a half y. And from here we can see that we can choose what? X to be 2 and y to be what? Negative 1. Let's check the second. Negative 125 times 2 minus 3 times negative 1 is negative a half, negative 1. So it's what? Negative 2.5 plus 3 is half. Yes, correct. So it's P2 lambda 2. Hence, our general solution expression for x in terms of t, so we write general solution. X, y is y, x, y, because we solve x derivative, y derivative is, and x, y is a. It's some constant to be found. A e to the power of lambda 1. Where is lambda 1? Lambda 1 is minus 5 over 2. T and multiplied by a vector. And vector is what? 2 and negative 5. 2 and negative 5 plus b e to the power of negative a half and 2 negative 1. 2 negative 1 and minus a half t. Its general solution and AB can be found, and it to be more clear, we can rewrite it as simultaneous equations or just expressions just for x, for y. So x is what? A and times 2, so it's 2a e to negative 5 over 2 t plus 2b e to negative a half t, and y, but what is y? Y is derivative of x, it's dx, it's dx over dt, but since x is displacement, It's actually velocity, expression for velocity with time, and it's displacement. And is what? Negative 5a e to negative 5 over 2t minus b e to negative a half t. And we need constants a and b, and there must be two points, two pieces of information. So it is given that when t is 0, displacement is 8. So x is 8 when t is 0, and also it is given that initial velocity is 0. So v of dx over dt is 0 when t is 0. So when t is 0, e to the power 0, 1, so it becomes 8 is 2a plus 2b, and velocity is the second. Also when t is 0, it becomes, and it's 0, so 0 is negative 5a minus b. And just so for a and for b, we can just divide by 2 the first, so it becomes 4. You may use substitution or elimination, doesn't matter. 4 is a plus b, 0 is negative 5a minus b, and we can see that we can add left side and sides and right sides. So we get what? 4 is a plus negative 5a, so negative 4a plus 0. So a is negative 1. A is negative 1. So b is 4 minus negative 1, it's 5. Or just negative 1 plus 5 to be equal to 4. B is 5. B is 5. A is negative. So finally, actually, what do we need? We need find expression for x. We need the expression for x only. So we need only this one. But in general, there may be question about velocity or something like that. So x as a function of time becomes 2 times a, what is a? A negative 1, so negative 2 e to negative 5 over 2t. What is b? B is 5, so 2 times 5 plus 10 e negative a half t. So it's the required expression for the displacement x with time in terms of t. And that's all for this question.